Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating article about the limitations of WASM GC in real-time graphics. It's a bit of a technical deep dive, but stick with us. It's going to be fun.
Ooh, sounds intense. WASM GC, right? I've heard whispers, but I'm not entirely clear on what the fuss is all about. What's the core issue?
So WASM GC is amazing. Managed memory in WebAssembly, meaning smaller binaries, better performance, and smoother integration with browsers. But there's a catch. The author, focusing on real-time graphics, found some serious performance bottlenecks.
Bottlenecks? Spill the beans.
Okay, so the first problem is that WASM GC heap objects are opaque to JavaScript, and vice versa. Imagine you've got an array of vertex data in your WASM code. To use it with WebGL and JavaScript, you have to copy each byte individually. That's a huge performance hit, especially for large datasets. It's like trying to move a mountain, one grain of sand at a time.
Wow, that sounds incredibly inefficient. So instead of direct access, you're forced to do a byte-by-byte transfer? That's crazy.
Exactly. Now, with linear memory, it's a breeze. You can directly access the data as an "array buffer". It's a much more streamlined process. The author even provides a hello triangle example in Scheme, compiled to WASM using Hoot, to illustrate this point. It's quite impressive, but also highlights the problem.
I see. So the second problem.
The second issue is manipulating multi-byte data. In WASM GC, reading a 32-bit integer from an array requires multiple instructions, one for each byte. It's a tedious process. Linear memory, on the other hand, uses a single "I32" load instruction. It's incredibly simple and efficient.
So it's not just the data transfer, but also the processing within WASM itself that's slower with GC? That's a double whammy.
Precisely. The author explores some workarounds, like using "uint8 array" from the host, but that just shifts the bottleneck to the WASM JS boundary, or using linear memory for byte vectors, which introduces memory management headaches. It's all a bit of a mess, really.
So what's the solution? Is there a fix on the horizon?
The author points to ongoing discussions on GitHub about multi-byte access and "array buffer" integration. But, it seems like a long road ahead. They even mentioned the rejected "stringref" proposal, which would have helped with string handling. It's a bit frustrating, you know?
Years to implement? That's a long time in the fast-paced world of web development. It's a shame, because it sounds like WASM GC has a lot of potential, but these limitations could be a real showstopper for certain applications.
Absolutely. The author uses real-time graphics as an example, but the same issues affect string handling. It's a broader problem than just graphics. It's a shame, because Web GPU is coming, and these limitations might prevent WASM GC from being a viable option for many developers. It needs some serious fixin', as the author puts it.
It sounds like a critical issue that needs addressing. Thanks for breaking it down for us.
You're welcome. That's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll catch you next time. Goodbye.
Bye-bye.